Where is everybody? The question that changed everything. Have you ever looked up at the night sky and wondered, are we really alone? It's a question that has fascinated humanity for thousands of years. Every civilization has looked at the stars and imagined what might exist beyond them. Ancient culture saw gods and myths in the sky. Today we see galaxies, black holes, and planets orbiting distant suns. But despite everything we've learned, one question remains unanswered. Where is everybody? That question wasn't asked by a science fiction writer. It came from one of the greatest physicists of the 20th century, Enrico Fermi. In the summer of 1950, Fermi was having lunch with a few colleagues at the Los Alamos National Laboratory. The conversation drifted toward flying saucers and the possibility of extraterrestrial life. Then, almost casually, Fermi asked a question that would puzzle generations of scientists. Where is everybody? It was only 3 words. Yet hidden inside them was one of the greatest mysteries in science. Because Fermi wasn't asking whether aliens existed. He was asking something much stranger. If intelligent life should be common, why haven't we seen any evidence of it? At first, that might not seem like a difficult question. After all, space is unimaginably vast. Maybe we've just been unlucky. But once you begin looking at the numbers, that explanation becomes surprisingly difficult to believe. Let's start with our own cosmic neighborhood. The Earth orbits an ordinary star called the Sun. It's not unusually large, unusually bright, or particularly rare. In fact, compared to many stars in our galaxy, the Sun is remarkably average. Around this average star orbit 8 planets. One of them, our tiny blue world, happened to develop life. For centuries, we didn't know whether planetary systems like ours even existed. It was entirely possible that the solar system was a cosmic accident, a rare exception in an otherwise empty universe. Then, in the 1990s, everything changed. Astronomers began discovering planets around other stars. At first, there were only a handful. Then dozens. Then hundreds. Today, we've confirmed thousands of exoplanets, and we've learned something extraordinary. Planets aren't rare. They're everywhere. Some are giant worlds larger than Jupiter. Others are rocky planets similar in size to Earth. Some orbit twin stars. Others race around their suns in only a few days. A few appear to lie within what's known as the habitable zone, the region where temperatures could allow liquid water to exist. And if we found thousands of planets while examining only a tiny fraction of the galaxy, how many more are waiting to be discovered? The answer is almost impossible to comprehend. Our Milky Way galaxy alone contains somewhere between 100 and 400 billion stars. Many of those stars almost certainly have planets, and the Milky Way itself is just one galaxy among hundreds of billions in the observable universe. Try to picture that. Every star you can see on a clear night is only a tiny sample of what's actually out there. Beyond them are billions of stars your eyes will never detect. Beyond those are entire galaxies, each containing billions more. The numbers become so unimaginably large that our brains stop treating them as reality. They're simply too big for human intuition, and that's exactly what troubled Enrico Fermi. If the universe contains such an enormous number of stars, such an enormous number of planets, and has existed for nearly 14 billion years, then shouldn't intelligent life have appeared many times? Shouldn't at least one civilization have become advanced enough to leave a visible mark on the galaxy? By the time humans invented radio, the universe was already billions of years old. If another civilization had begun even 1,000,000 years before us, a blink of an eye on the cosmic timescale, it could be unimaginably more advanced today. So why don't we see them? No unmistakable radio messages, no colossal structures surrounding distant stars, no probes, no visitors, no undeniable evidence that anyone else has ever been here. Just silence. And that silence is what we now call the Fermi Paradox, the Great Silence. So, what exactly is the Fermi Paradox? Surprisingly, it isn't evidence that aliens exist. And it isn't evidence that they don't. It's a contradiction. On one hand, everything we know about the universe suggests that intelligent life should be common. On the other hand, we've found absolutely nothing that proves another civilization exists. Those two ideas don't seem to fit together, and that's the paradox. To understand why, imagine you're standing on a beach. You pick up a handful of sand and let it run through your fingers. Now imagine every grain of sand represents a star. You'd need countless beaches just to represent the stars in our own galaxy. Somewhere among those stars are billions of planets. Surely at least a few of them had the right conditions for life. After all, life on Earth appeared surprisingly early. Our planet formed around 4.5 billion years ago. The earliest evidence of life dates back almost 8 billion years. That means life emerged only a few 100 million years after Earth had cooled enough to support oceans. In geological terms, that's remarkably fast. If life began so quickly here, perhaps it happens whenever the conditions are right. And if that's true, the universe should be full of living worlds. Of course, simple life is one thing, intelligent life is another. Single-celled organisms dominated Earth for billions of years before anything resembling complex animals appeared. Then came fish, reptiles, dinosaurs, mammals. Finally, after nearly 4 billion years of evolution, humans arrived. Our entire recorded history, the pyramids, the Roman Empire, the Industrial Revolution, the Internet, space travel, all fits into the tiniest fraction of Earth's history. If Earth's history were compressed into a single calendar year, modern civilization wouldn't appear until the final seconds before midnight on New Year's Eve. We're incredibly young. That realization makes the silence even stranger. Because if another civilization started only 1 million years before us, they wouldn't be just a little more advanced. They would be unimaginably beyond us. 1 million years sounds enormous to humans, but in a galaxy that's over 13 billion years old, it's almost nothing. A civilization with a million-year head start could have explored much of the Milky Way. It could have built technologies we can't even imagine. It might have transformed entire solar systems. So, where are they? Scientists have spent decades trying to answer that question. And while nobody knows the truth, there are several fascinating possibilities. The first is surprisingly hopeful. Maybe intelligent life is incredibly rare. Perhaps planets are common. Perhaps simple life is common. But the leap from simple organisms to intelligent civilizations almost never happens. Think about everything that had to go right for us. A stable star, liquid water, a protective magnetic field, plate tectonics recycling nutrients, a large moon stabilizing Earth's tilt, mass extinctions that cleared the way for mammals. Countless unlikely events, stacked one upon another. Maybe remove just one of those. And humanity never exists. If that's true, Earth may not be ordinary at all. It may be extraordinarily lucky. But there's another possibility, one that's much darker. Perhaps intelligent civilizations don't last very long. Imagine a species discovering fire, then electricity, then computers, then artificial intelligence. Its technology advances faster and faster, but so does its ability to destroy itself. War. Climate collapse, engineered pandemics, runaway technologies, nuclear weapons. Every civilization may eventually reach a point where its power grows faster than its wisdom. Perhaps many never survive that stage. Scientists sometimes call this idea the Great Filter. Somewhere between lifeless planets and galaxy-spanning civilizations, there may be an obstacle so difficult that almost nobody gets past it. The unsettling question is this: has humanity already passed that filter, or is it still waiting for us in the future? The distance between worlds. The Great Filter isn't the only explanation. In fact, it's possible there's nothing mysterious happening at all. Perhaps the universe is simply too big. We often talk about space as though it's crowded with stars, but what we don't appreciate is the emptiness between them. The moon feels far away. It takes light just over a second to travel from the moon to Earth. The sun is much farther. Its light takes 8 minutes to reach us. That already sounds enormous. But the nearest star beyond our sun is Proxima Centauri. Its light takes more than 4 years to arrive. That means every time astronomers look at Proxima Centauri, they're seeing it as it was over 4 years ago. They're looking into the past. Now imagine trying to cross that distance. The fastest spacecraft humanity has ever built, the Parker Solar Probe, travels at nearly 700,000 kilometers per hour, an incredible speed by human standards. Yet even at that speed, it would still take centuries to reach our nearest neighboring star. And that's just the closest one. The Milky Way itself is around 100,000 light-years across. Even if a civilization mastered interstellar travel, crossing an entire galaxy would remain a monumental challenge. Perhaps intelligent life is everywhere. Perhaps thousands of civilizations exist at this very moment. each one separated by distances so vast that they're effectively isolated from one another, like tiny islands floating in an endless cosmic ocean. If that's true, the silence isn't surprising, it's inevitable. But there's another idea, one that's become surprisingly popular in science fiction. It's called the dark forest hypothesis. Imagine walking alone through a dark forest at night. You hear movement in the trees. You don't know who's out there. You don't know whether they're friendly or dangerous. In that situation, would you shout to announce your position? Probably not. The dark forest hypothesis suggests that every intelligent civilization faces the same dilemma. The universe may be full of life, but everyone stays quiet, not because they're hiding from us specifically, but because revealing your location to an unknown civilization could be the greatest mistake you'll ever make. It's a chilling thought. Fortunately, there's no evidence that it's true, but it reminds us of something important. Our assumptions about alien civilizations are based almost entirely on human behavior. The truth may be something we've never even imagined. There's another possibility that's easy to overlook. Maybe we're searching in the wrong way. For decades, we've listened for radio signals, but think about how quickly our own technology has changed. 100 years ago, radio was revolutionary. Today, much of our communication travels through fiber optic cables, lasers, and tightly focused satellite transmissions. To a distant observer, Earth may actually be becoming quieter. If technology changes that much in a single century, what would a civilization 1,000,000 years older than us be using? Perhaps we're listening with the cosmic equivalent of an old AM radio, while everyone else has moved on to something beyond our understanding. If so, their signals could be passing through the universe unnoticed while we wait for a message that will never come. And maybe, the strangest possibility of all is that we've already found life. Not intelligent life, not cities among the stars, but the building blocks. Scientists have discovered organic molecules drifting through interstellar space. They've found water in distant solar systems. They've identified planets that may have oceans beneath frozen surfaces. With every new telescope, the universe looks a little less empty than it did before. Perhaps we're witnessing the opening chapter of one of humanity's greatest discoveries. Or perhaps we're learning just how incredibly rare intelligent life really is. Either way, the search has only just begun.